Captain's Log, Stardate 2023.37. Or is it Stardate 2302.06? No, wait, hang on. Take that times 365, or is it divided by 365? Captain's Log, Stardate 277000000.
Welcome to the Trevor Meyer Show. I'm Trevor Meyer, and today we're going to answer the question, how the fuck do Stardates work? I feel a lot better about using profanity in my videos now that I know that it'll bleep it out automatically. And, you know, if Star Trek can use F-bombs now, then why can't I? Greetings, fellow Trekkies. Even if you are a Trekkie, you gotta be like a hardcore Trekkie to really actually care about this, all right? Even people who love Star Trek don't care this much about what I'm about to talk about. So, but if you like Stardates, if you like puzzles, if you like code breaking, if you like secret languages that only you and a few others can understand, this is the kind of crowd that this video is for.
And if you're thinking, I already know how Stardates work, I'll just look it up on Memory Alpha, I'll read an article, I'll watch another YouTube video, it'll be fine. Everybody in the Star Trek community has a pretty good idea of how Stardates actually work. But keep watching, because I promise you, you're going to hear something new here, all right? Because I've, as they say in Jurassic Park, I have read what others have done and I've taken the next step. Most of the work was done for me, but I put the pieces together in a new way that I can't find anywhere else on the internet. Now, if you're watching this, I assume you already have some idea what a Stardate is, at least. And if you don't, just very briefly, I'll tell you that it's how they measure time in the Star Trek universe. It's usually associated with the captain's logs that they usually put at the beginning of the episode.
Captain's log, Stardate 1513.1.
And the whole point of Stardates initially was to avoid mentioning what the actual year was so that people wouldn't debate about whether or not it was realistic. So for a while, they couldn't decide whether it was in the 23rd century or the 22nd century or the 24th century. They're like, sometime in the future this is. So they come up with a star date, which is like a fake year. The reason I started trying to figure this out in the first place is just because I have a journal that I write in occasionally, and some of it I recorded voice recording while I was driving. And just for fun, I used to want to say, Captain's Log, Stardate, whatever. And I really wanted it to be in the actual format that they used in the real movies and TV shows in the prime timeline. But I couldn't figure out how to turn today's date into a Stardate. And everywhere I looked, they told me it was impossible. It's nonsensical. There's no way to actually do it. And for a long time, I believed them. So I looked for alternatives, like, for example, how they do things in the Kelvin movies.
Captain's Log, Stardate 2263.2.
The way they do it is you do the actual year, point, and then what day of the year it is. So if it's 2022, it'll be 2022, point, and then today is 355. So in the Kelvin timeline, this would be 2022.355.
And that worked. I mean, I used that system for like 2 years because it actually made sense. It was more concrete. And as far as I could tell, the original version of how Stardates worked couldn't be translated into our time. The Kelvin movies, at least, there was a way to convert our date into their date. So I ran with it for a while, but it's still like, it bugged me a little bit because it didn't really sound like a real star date, because for the first 9 days, you would have a 1 digit after the point. It would be 0.1 through 9. For the first 99 days, for example, you could have, 2022.99, and the original series would sometimes go out to 2 digits like that after the point. But once you got to day 100, for most of the year, you'd say like 2022.232. And they almost never did that on the original series. They almost never went out to 3 digits. So it always felt like kind of a cheat. It always felt like that's not really how they do Stardates. later I did find out about another way to do Stardates that's not really how they do it in any of the shows or movies, but it's kind of a fun way that can sound like a Stardate. You know, it's got the format of a Stardate, even if it's not really how they do it in the show.
Back in the 70s and 80s, I think, they did these Star Trek Stardate calendars. And what they would do is you would just write out the date the way you normally would with the month, day, year. You just put the year at the beginning. So if it was 1979, it would start with 7/9. And then if it was January, 01. And then point whatever the day was, like 01 if it was January 1st. So right now would be 2212.21.
For the record, that method to me wins the award for the most amount of fun for the least amount of effort. You're literally just writing out the date the way that you always do. You're just rearranging the numbers to make it look like a star date. So it's fun, but I still wanted to know how they actually do it. But let's go back a second to this objection. Why do people say that star dates are nonsensical? Why do they say they make no sense? And I understand where they're coming from.
The reason why there's never going to be a formula that can consistently produce the star dates that we see in the movies and TV shows is because star dates are inherently chaotic. They're a little bit random, a little bit, volatile. So they will go faster, slower, backward, forward, but generally have a forward progression that is linked with linear time.
Now, this is what I'm talking about here. Memory Alpha actually arranges the episodes of the original series in the order they were shot, as in their production number here, not in the order that they were aired. And I think that helps sort out the star dates a little bit, because part of the reason why the star dates were so chaotic originally was because the episodes were aired out of order. So when you put them in production order, they make a little bit more sense, but it's still not perfect. Start in the 1300s, go to the 1500s, 1300s, 1600s, 1500s. Now, it's jumping around, but note that for the most part, the first digit stays the same. We're in the 1000s for all of this until we get down to there. Then we're in the 2000s. And then we stay in the 2000s, get up to the 3000s, back to the 2000s, up to the 3000s. And we're in the 3000s. Stay there, go to the 4000s briefly, then we're back to the 3000s. 4000s again, 3000s, 4000s, 3000s, 4000s, 4000s, 4000s. And then season 3, 4000s to the 5000s. Staying in the 5000s. Staying in the 5000s. All right. So you can see here that even though, like I said, they go backward, forward, faster, slower, they're kind of all over the place, and yet there is a general forward progression. It goes from the 1000s to the 2000s to the 3000s to the 4000s to the 5000s. And then when we get to the animated series, which continues the 5-year mission, we start again in the 5000s. Then we jump back to the 1000s very briefly. 5000s again, 4000s, 5000s, 4000s, 5000s, 6000s, 7000s, 3000s, 5000s, 6000s, 6000s. Now again, lots of spikes there, but it's still worth noting that the original series begins in the 1000s and the animated series ends in the 6000s, and that's roughly 5,000 star dates. And if we talk about star dates happening at a rate of 1,000 star dates per year as established in Next Generation, it still fits.
And the writers have given an explanation, a sort of hand-wavy explanation for why the star dates vary so much, and they say it's because the warp drive alters the space-time continuum so that different parts of the galaxy would have different star dates. So the star date on Earth would not necessarily be the same as the star date on Alpha Centauri, which people often take to mean that, like, oh, well, that's why star dates don't make any sense. Pay it no mind. There is no logic to this system at all. But I don't even think we need to go that far. I think that that explanation just accounts for the small amount of variability that we get in the star dates, even though there is still a linear progression through time, which is what we would expect. Like, even if there was a time distortion, time still passes, just at different rates because of the warp factor.
So the formula I use to calculate today's star date wouldn't actually give you the exact star date that we see on the TV shows and in the movies, but what it does do is calculate the flat underlying trend line behind it to get an approximation.
Luckily, I did not have to make up a formula because there already was one, but it did have one significant problem that really bothered me.
This has been well established in Star Trek lore ever since Star Trek The Next Generation. Season 1 of Next Generation, the star dates were the 41,000s.
Captain's log, Stardate 41153.7.
Season 2, 42,000s. Season 3, 43,000s. So it goes up by 1,000 every year. And we know what years they take place in. So you can go forward to the year 3188 as Star Trek Discovery did.
Stardate 865211.3.
And they actually do keep it pretty consistent with what came before. It gets a little bit wonky later on, but as you can see, if you just walk it back a few years, you realize the problem with this is that you hit Stardate 0 in the year 2323, which is an issue because the original series happens in 2265, and it's in the 1000s.
Captain's log, Stardate 1513.1.
So what happened here?
People are so quick to dismiss the original series era star dates. They just throw their hands, even the writers, they just throw their hands up in the air and say, everybody knows that those star dates don't make any sense. Why do they think that, though? We've known the whole time. It's on Memory Alpha. It was part of the initial conception of star dates to base them on the Julian Day number.
And this is a real thing. Like, the Julian Day number is an actual, not a countdown, a count up from an astronomical event that happened many thousands of years ago. So they picked a significant point. It's pre-human space travel, and they just picked a point in astronomical history to start as their 0 point, and they've been literally counting days ever since then, and it's a long number.
Because the starting point, or reference epoch, is so long ago, numbers in the Julian Day can be quite large and cumbersome. A more recent starting point is sometimes used, for instance, by dropping the leading digits.
See here, the Julian date is 2459975.40972. But the reduced Julian date is the exact same number with the 2 and the 4 cut off the beginning of it to turn it from a 7-digit date into a 5-digit date. And according to Star Trek 30 Years Special Collector's Edition, published in 1996 by Paramount Pictures, Roddenberry borrowed the 5-digit Julian date, shortening it to 4 digits and renaming it Stardate. This was always part of how Stardates were conceived. In fact, originally they were going to actually literally make it the Julian Day number, but the math became too difficult to maintain, so they're just like, just throw any 4 numbers up there, it's fine. But it's supposed to be the end of a longer number.
And you might think, wasn't it short-sighted of them to use a system where they knew they were going to run out of digits pretty soon? And yeah, it was, but we've seen this in real life too with Y2K. Wasn't it short-sighted to write computer programs with only the last 2 digits of the year, knowing that when it rolled over from 99 to 00 that it would screw up all the math and all the computer programs and that we'd have to scramble to turn it to a 4-digit system all of a sudden? But we did it. That's what happened. But if we know that there are 1,000 Stardates in a year, and you only get to use 4 digits, how much information can we expect to get out of a number that repeats every 10 years? So after the 9,000s, it's back to 0 again. So if decades passed in the Star Trek universe, how would we know from a 4-digit Stardate that 10 years passed? If 10 years pass, the Stardate stays the same. Because there is no decade digit. There's only a year digit, and then tenths of a year, hundredths of a year, and thousandths of a year. Of course, it's going to be obscure and confusing and not make any sense until they added that other digit and brought it out to 5. I imagine that if Stardates were kind of new, they didn't decide they needed 5 digits for clarity until the Next Generation era, or slightly before that.
So you could say that the original series uses a totally different Stardate system, but why would you? It totally fits with the format of Next Generation if you accept the fact that some of the digits have been cut off. Like, there's no reason to dismiss them. So now that I've locked on to this theory that there are hidden digits in there somewhere, I just don't know what they are yet, I started filling in some like phantom numbers, like just put extra 9s in front of it or extra 0s at the front of the number just to see if I could make the math work. And what's interesting is the original series, TV shows and movies are what I call the Kirk era of Star Trek. It starts in the 1000s and it ends in the 9000s, which is a nice, neat little thing that it's all the 4-digit range. It goes from the 1000s all the way to the 9000s. Isn't that cute? But people have had a problem with the fact that, like, in the TV series, original series and the animated series, it seemed to go up by about 1,000 Stardates per year, which is the same as Next Generation. But later down the line, in the movies, the original series movies with Kirk, they would seem to go up by 1,000 Stardates every decade. All right, so the first digit would roll over every decade instead of every year. So most people will say, that's a different system. Again, it's changed. Again, this is a different Stardate system. But really think about it. Does that actually make sense? From the beginning of the series to the end of the movies, it goes up by 8,000 Stardates, or 8 years. Or if we're cutting off the first digit, it could be 18 years, or it could be 28 years, which is how much time passes in real life from the first episode of the original series to the last movie with Kirk in it. It's how much time passes in universe and in real life. 28 years pass, which, if you cut off the first digit, is 8 years, which is 8,000 Stardates, and that's how many Stardates go by in the Kirk era of Star Trek. Isn't that a weird coincidence? In fact, in Wrath of Khan, they reference video footage that was supposedly recorded a year ago, and yet it's 1,000 Stardates earlier. So in the movies, if we're supposedly saying that they advance by 1,000 Stardates per decade, it's weird that the Stardate goes back 1,000 when they're looking at 1-year-old video footage. So yeah, I started out with just made up digits. I used to just like fill it in with like X's or whatever to figure out the math of how you work the original series Stardates into the Next Generation formula. But then a miracle descended from the heavens to solve my problem for me.
This number right here is the missing piece of the puzzle that actually came about pretty recently and was great for me trying to figure out this Stardate formula. This is the longest Stardate ever recorded in Star Trek canon, the canon being the movies and the TV shows. This appeared on a legal document in Star Trek Discovery. Now, it's longer than the dates that they've been using on that show. The one before it is that, and the one after it is that. So, if we were to fill in some of the missing digits that have been cut off, it would probably look like this. Now, that middle number is still a huge spike, but that's actually the smallest amount of variation we can have and still have the other numbers be intact. So, if we take the hidden digits that we've learned from Star Trek Discovery and apply them to what we've known of the Star Trek timeline so far, it all starts to make a little bit more sense. So, if you think of the first season of the original series starting in 2264, the blue digits are the ones I've filled in using this information. And the 1000s is what they actually tell us in the captain's log for the episode. The end of the animated series, 5 years later, the end of the 5-year mission, is in the 6000s, and the last episode is in the 6000s. The last movie, 2292, it was in the 9000s, but really it's 2796 9000. And it carries through to here with the missing digits filled in. Now, I did fudge these numbers by a year, but as we know, there is some variability.
Yes, it's true. For that demonstration, I did fudge the numbers by a year for the sake of simplicity. Actually, if you were to count backward from Next Generation, everything on that timeline should have happened 1 year earlier than it actually did. So on the timeline, I wrote that the original series started in 2264. It actually started in 2265. And the beginning of Star Trek Generations, the last time we see Kirk, at least in the original series era, I said it was 2292. It was actually 2293.
The other way to look at it is that the original series should have started in the 2000s, and the movies should have passed through the 9000s, and Generations should have taken them to the 0000s. Now, on the one hand, I can see why that would be not as aesthetically pleasing to start in the 2000s and end in the 0000s, as opposed to starting in the 1000s and ending in the 9000s, which just sounds a lot nicer. But also, we're kind of approaching the problem backwards, aren't we? Because they weren't thinking of any of that when they made the original series, because we're going backward from the Next Generation. So when they started the original series, they decided that year one would be the 1000s, all right? And roughly speaking, each progressive year past that would be another thousands. And they decided the same thing with Next Generation, that year one would be the 1000s, year two would be the 2000s, and so forth. So what's the problem here? Well, this would work perfectly if the Next Generation took place 100 years after the original series. But it doesn't take place 100 years after the original series. It takes place 99 years after the original series, which is why everything is off by 1 year. And that's kind of like the real world explanation for this, is that it's 99 years later instead of 100 years later, and that's why everything's off by a year. But if you still want year one to be the 1000s, which is what I would do if I was writing a new series in Star Trek, and it wasn't like happening in tandem with another Star Trek series, I would probably make season one the 1000s just for the Stardates to advance that way. You know, it'd just be easy for it to go up by 1000 every season. I do wish that Next Generation had taken place exactly 100 years later, because then this would have been perfect. Everything would have fit perfectly, but this is just like one little glitch that bugs me. In universe, though, the only way to explain everything being off by 1 year is to take into account that variability and manipulation by the warp factor. And even just looking at the animated series, we've seen spikes of up to 4 years. You know, Stardates have fluctuated by plus or minus 4 years in the original series era. So despite the underlying trend line, they are quite chaotic. So it's not that unusual for them to be off by a year. And if you allow for that little bit of fluctuation, the Next Generation format still applies.
If this is true, and we could take it at face value, Stardate 0 happened in the year 25677 BCE. This is before humans have discovered warp travel. This is before the Vulcans discovered warp travel. If humans were using the Julian Date number, then Vulcans maybe had a different event that they were aware of that the humans didn't know about, in which case that could be a good starting point. And I understand why there might be some resistance to this theory, because it goes against what people have been saying all along, which is that the Stardate format changes over time. Now, you can keep believing that if you want to, but if you did that, you would have to ignore the fact that they were always based on the Julian Date number.
And just like with the Julian Date number, if this true Stardate were actually 8 digits long, then yes, it would be quite large and cumbersome, and you might want to abbreviate it by dropping the leading digits. Because
who's going to want to say an 8-digit stardate in their captain's log every time when I'm sure somewhere in their computer database the full stardate is there. They know what the real stardate is, so there's no reason to say the whole thing when they're doing a captain's log. So yes, of course you would abbreviate it. Then it seems like a bad conclusion to reach, to say that the original series stardates don't match the next generation format when we don't have nearly enough information to make that conclusion, and the evidence is actually pointing to the contrary, that it is all one same system based on the Julian Date number. And if you don't want to use that number from Star Trek Discovery on that Armistice legal document, that's fine. Like, I could see that maybe you think that's just an Easter egg, that's not a real star date. It was just thrown in there for fun. However, it is on Memory Alpha. It is readable. It's part of the canon. So something more stable and more canonical may pop up at some point. But until then, we have that number. We can use that number. And if we got rid of it, if we wanted to fill in those extra digits, we would just have to make up numbers anyway. So why not use something that's actually part of the canon?
And no, not for a second do I think that this was the plan all along. This is a fan theory. This is a coincidence that works out really well in retrospect. Of course, they didn't have a plan going into it in 1966. They didn't know that Next Generation was going to be a thing. But it still works as a fan theory. Going back, and it's just dumb luck that it actually fits.
Hang on a second. They weren't using stardates on Enterprise. That was 100 years before the original series. How do you explain that? Well, it's true. Humans were not using stardates 100 years before the original series, but Vulcans were. All right? Vulcans and other species do make reference to stardates even before Starfleet started using them because the Federation had not been formed yet. I imagine that at a certain point, they must have come to a compromise. So the event that is the 0 point for stardates is relevant to Vulcans, but when they formed the Federation, they put it into Earth time, as in how many Earth years passed since that event that was significant to the Vulcans. That would seem like a good compromise to me. And no, there's no actual canon evidence to suggest that, but I do think that there has to be a reason why it's in Earth time. Everything about the Stardate formula is based on Earth time, but why? The only thing about it that doesn't seem to be inspired by Earth time is the fact that Vulcans were using it first, and it references an event way before the Julian Date number. So I'm thinking some kind of compromise must have been involved here. So they weren't using stardates yet, but the stardates did exist. So assuming that you're still with me here and you're willing to follow me on this journey, let's dive a little bit deeper into what the actual format of a stardate is and what units they're using to measure it.
All right, let's use Stardate 2000.1 as an example just to keep things simple. What is this? What 2000.1 what is the unit of a stardate? And that is kind of a trick question because it's two different numbers. This is not one number. It's not 2000.1 anythings. The more accurate way to write this out is 2000 stardates, semicolon, 0.1 days. And it's not plus. You're not adding 0.1 days to 2000 stardates. Stardates is its own unit. So 0.1 days is just another measure of time that doesn't have anything to do with the stardate.
Now, because this is not actually one number, sometimes it looks like the stardates are going backwards. Let me show you an example. The other day, the stardate was 10.9. After midnight, it was 10.0. Why was it 10.0? Did it go backwards? Not really, because the tenths of a day digit rolled over from the last tenth of the day to the first tenth of the next day, but this isn't days, this is stardates.
And just to get real clear on what that progression looks like, let's follow the timeline. We went from that day, 10.0, to 11.1, so the day number went up by a tenth of a day, but also the stardate advanced by 1. So we skipped all the other 10s and went up to 11, 11.2, 11.3, 12.4. So you see how this works? So the number before the point progresses steadily, 10, 11, 11, 12, and the number after the point progresses steadily, 0.0, 0.1, 0.2, 0.3, 0.4, but not at the same rate. So here it looks like we skip, 11.4 through 12.3, but we don't really skip it because that's not how these numbers work.
It's sort of like weeks and months, like if you took the week and the month and you smashed it into one number, well, just because it's Monday doesn't mean it's the first of the month, and just because it's the first of the month doesn't mean it's Monday, So they're not going to roll over at the same rate. They're not connected that way.
And now for the moment we've all been waiting for. We've been through all the backstory, we've been through all the background information, we've talked about the units. Let's get to the formula itself of how to calculate today's stardate.
So based on the calculations we did earlier, counting backward from Next Generation using the missing digits that we got from Star Trek Discovery, we know that midnight on January 1st, 25677 BCE is literally Stardate 0. No other hidden digits, nothing like that. It's just a 0. That's where whatever phenomenon happened back then that they decided was a good starting point for Stardates, that's where the countdown or the count up begins. Okay? So, to figure out today's Stardate is pretty simple. You take that number, 25677 BCE, plus the year that it is right now that I'm making this video, 2023, all right? And that is how many years have passed since we started counting, 27,700. And then to convert years into star dates, you multiply that by 1,000, and that gives us 27,700,000 star dates, which, again, is like the Julian Date number, but just a little bit bigger, all right? So that's how many star dates have passed before midnight on January 1st, 2023.
So just like the timeline that we did earlier, this will tell you what the star date was at the beginning of 2023, or at the beginning of whatever year you're calculating. And at the beginning of the year, the star date always ends with 000.0. But then you got to figure out how far into the year you are to get those last few digits in there.
So when I calculate the star date, I'm actually going to work a little bit backwards because I'm going to need to know what 10th of the day I'm in order to calculate the main part of the star date before the point. So I need to figure out what the number after the point is first. So this works really well if you have a 24-hour clock. So on my phone right now, it says it's 14:05 or 2:05 p.m. Okay, so I want to figure out how many minutes have already passed today. So 14 hours times 60 minutes plus the 5 minutes, all right? So that's how many minutes have passed in the hour slot plus how many minutes have passed in the minute slot. So 14 times 60 plus 5 equals 845. That's how many minutes have passed already today. And I divide that by how many minutes there are in a day. All right, there are 1,440 minutes in a 24-hour day. And that gives us this number. And I just use a calculator for this. Now, here is a really important point about how Stardate format works. You always round down.
Which is how we measure time in real life too, right? I mean, even if we're like 99% of the way through the year 2022, we don't round up to the year 2023. It stays 2022 until literally the last second of the year. And then only after midnight do we cross over to 2023, in which case we round down for another whole year to 2023 until we cross over midnight again. And same with the display on a clock. So if it says 11:59, even if it's 11:59 and 45 seconds, the clock doesn't round up to midnight. It stays 11:59 until it's literally 00:00:00.
So the good news here is you don't really have to do any math here. We're just gonna get rid of everything except for the 5. That's it. That's what goes after the star date. It's 0.5.
And the other cool thing about this part is if you want that extra degree of precision that they sometimes have, where you bring it out to 2 digits past the decimal point or 3 digits past the decimal point, you don't have to do any other math here. Just leave those digits there. Just don't erase them. The information's already there if you want it.
So now that we know what 10th of the day it is, now we go back and figure out the star date, okay? So right now it's January 28th. And this is why we needed to figure out the 10th of the day first, because we need to know how much of this year has already passed. And not all of the 28th has passed. We're still in the middle of the 28th. So 27.5 days have passed so far this year. 27 being everything before midnight today, and 0.5 is what we just figured out how far into today we are, okay? So we take that 27.5, divide it by how many days there are in this year. If it's a leap year, you divide by 366, not 365, but this is not a leap year, so 27.5 divided by 365, that's how you figure out what portion of the year you are through currently. And then to convert that to star dates, because remember, there's 1,000 star dates in a year, you have to multiply that number by 1,000, and that gives us 75.342, and there's more digits after that, but it doesn't matter because you will not use the digits after the point. You can't do that with star dates because you need to put the portion of the day right here, not the portion of the year or the portion of the star date. So we have to get rid of these numbers here. And it'll leave us with 75. Again, it's rounded down. That's why you just chop off all those numbers. You don't need them anymore. So again, just to review what we've talked about before, we started at Stardate 0, which was 25,677 BCE, added 2023 to it to figure out how much time had passed, which is 27,700 years. Multiply that by 1,000 to get the star date. And then we knew that the beginning of 2023 was 27,700,000 star dates. And then to that, we have to add today's star date to get the last few digits. Today's star date is 75. So the actual star date, unabbreviated, the unabridged version of today's star date, is 277,00075. And then you would add the 0.5 right here to represent that half of the day is over. So you can see why they would want to abbreviate this. I want to. So like, I don't want to read Captain's Log Stardate 277,00075 every time. Of course, if I'm in Next Generation, I would do 00075. Or if I'm in the original series, I would just do 0075. But why have those extra zeros there at all? I'm just going to say Stardate 75. Or, for the portion of the day that has already passed, 0.5. So if you were going to read today's star date, it would be Stardate 75.5. This is it. This is the formula that you would use, and then just change the year, whatever the year happens to be. This will last forever. You can even use it to figure out the star dates in the original series if you want. Multiply by 1,000 to figure out how many star dates have passed. Put in the portion of the year that has already passed to figure out the true star date, and then abbreviate it however you see fit.
Now, if you're in a situation where you need to calculate the star date, where you don't know the exact time, because the time of day will affect which star date you're in, because the star date is just under 9 hours long. So if you're thinking of like a birthday or a holiday or something like that, but you don't have a specific time of day, I would just do 0.5, because then you have a 12-hour margin of error in either direction. If you pick midnight on that day, then if you're off by 1 minute, you're on the wrong day. If you pick noon on a particular day, it's the center star date for that day.
Now, let's go over how to convert it back the other way. And this is actually the trickiest part of the whole process. Converting our time into a star date is the easy part. Converting it back the other way is a little bit trickier and takes a little bit more math work. And just to show that you can use this for any star date, I have randomly generated an 8-digit star date. Looks to be pretty far in the future. So here's how you would convert it
back into our time.
And for the sake of this demonstration, let's just assume that they did not give us the portion of the day, as in the point something after the stardate. Let's say we only know the actual stardate, which is often true in Star Trek of like historical records. They'll say the stardate, but they won't say what portion of the day they're in. So because we don't really know when in this stardate it is, it could have just rolled over to 1, or it could be 1 second away from rolling over to a 2. We don't know, because it's been rounded down. We know that from before. So we have no idea where in 841 we are. So to give us the most accurate answer, we should assume that it's about half over. So I'm just going to add a 0.5 to it to say that the stardate is half over. Now that is a real 0.5. That is half a stardate, not the kind of 0.5 that we talked about earlier where it's half a day. That's half a stardate. We're halfway through 841. So to convert it to years, we know that we have to divide this by 1,000. So we just got to move that little decimal point from there to there. And that is how many years have passed since Stardate 0, which was 25677 BCE. So since this original 0 point, 85,984.8415 years have passed. So how do we figure out what year it is in the Common Era? Well, pretty simple. You just take that number here, the number of years that have passed, minus Stardate 0, 25677 BCE, and that gives us the year 60307 CE. All right, that's the year, 60307 CE, and then this number right here tells us what portion of the year we're into at that point. So to figure that out in days, we do 0.8415 times 365, and we know it's 365 because it's not a leap year, because the year ends with a 7. If it were a leap year, we'd multiply by 366, but in days, we know that we are 307.1475 days into the year 60307. So, here's the fun part. Now, if you know the cumulative day total like you would if you were using ordinal dates, then you could just subtract the cumulative day total of all the months that have passed so far. But if you don't have that memorized, then you can just take a calculator and subtract 1 month at a time. So we start with 307 days, minus 31 days for January, minus 28 days for February, March, April, May, June, July, August, September, October. And this is why it's useful to do it with a calculator, because if you track the running total, you can see when you get to a point that's less than a month. So once we get to 3, we know we have to stop subtracting, because November clearly has not passed yet. So we know all the year through October is already over, which means we are 3.1475 days into November. 3 days have already passed, which means we're in the 4th of November. So, if this is right, then it is November 4th, 60307 CE. Now, there is that margin of error that we talked about before, because we added half of a stardate to this because we don't know if it's at the beginning of the stardate or the end of the stardate or somewhere in between. But when we aim for the middle, we know that most of that stardate that we had up here happened on November 4th. We know that this is probably the date that translates into. Now, if that's close enough for you, you don't really have to worry about this part. But if you want to be a little bit more exact, then we have to look at that margin of error. And that is plus or minus half a stardate converted into days. And that'll give you the 0.1825 margin of error. So 3.1475 plus or minus 0.1825 would give us a range of 2.965 to 3.33. So the very end of November 3rd to the first few hours of November 4th. That stardate could be anywhere within that range. But on the off chance that they do happen to include the portion of the day, and it's been properly calculated,
then all the ambiguity is removed. As long as you have this, and this is probably why they do this, as long as you have what portion of the day you're in, this is not ambiguous. You know exactly what the Gregorian date is, because if you look at point 3 is definitely within the range of November 4th.
Because anytime you have a split like this, where it could be one day or the following day, the portion of the day is always either the end of the first day or the beginning of the second day. So you can tell when you look at the portion of the day whether you're at the end of the day or the beginning of the day, because it's not like you're at the beginning of November 3rd. That's not possible. That's outside the range. Nor are you at the end of November 4th. That's also outside the range. So you're either at the end of November 3rd or you're at the beginning of November 4th. So if you know if you're at the beginning or the end of the day, that'll tell you which day you're in.
So this will always work. It does correlate with our measurement of time. And I was very excited to figure all of this out in 2022. The reason being that in 2023, we crossed over into a new Stardate century, meaning that we crossed over from Stardate 99999.9 to Stardate 00000.0, which is just so cool. And what it means is, for me personally, and why I'm excited about this, is because I get to start counting Stardates now, the abbreviated form, when you cut off the zeros and bring it down to 5 digits or less. I get to start with 1-digit Stardates, and then 2-digit Stardates, and then 3, and then next year, 2024, it'll start to 4-digit Stardates, and then after 10 years, it'll go over to 5-digit Stardates, and it'll be that way for the rest of my life. And at that point, it'll be in next generation format, which will just make me so happy. It's true. All of this started because I wanted to be able to put the real Stardate in my journal. Simple goal that I have achieved. So what do I want now? What is the point of this video? I mean, I already knew all this. So what am I trying to accomplish here? Pie in the sky. I want this to be canon. All right? I want the people who are in charge of Star Trek to make this a part of how they write the TV shows and the movies going forward. I would love it if they would actually even mention some of the stuff in here. You know, how the digits have been cut off of the Stardate, of where Stardates started in the first place. Keeping the Stardates consistent. If you have a 4-digit Stardate, once you get to 9999, have it roll over to 0000. That's what I would do if I was writing Discovery and Strange New Worlds right now. If Discovery was year 1, and we say we're starting in the 1000s, if we got to like a Strange New Worlds season 7 or 8 or 9 or whatever would be the equivalent of year 10 of Discovery. But if Strange New Worlds ever gets to the point where if they're advancing 1,000 Stardates per year, I know they've already messed that up, but I would have them start getting back on track so that every year that goes by, 1,000 Stardates go by, and then if they ever get to year 10, roll it over to 0000 just to validate this theory. So what I need you to do, my friend, is share this with every single Star Trek fan you know. All right? If you're watching this right now, I need you to send this video, click the share button, copy the link, send it in a text message, Facebook, wherever you gotta go. But share this with every person who will listen. And hell, if you know somebody who is working on Star Trek right now, who is like actually over there at Paramount making these things, send it to every crew member, every writer, every director at Paramount. All right? I want this to be legitimized. I want this to be real. I want them to acknowledge that, no, maybe this was not the plan all along, but it should be. What I have told you today is not canon. It's based on canon, but it's not canon. But I want it to be. I want them to make this canon because it makes so much sense and it solves so many problems for them. All right? It legitimizes the Stardates of the original series. It unifies everything. It gives it a deeper backstory. Everybody wins here. I want this video to go viral in a very specific and maybe slow way. I want it to go viral specifically within the Star Trek community. I want everybody to be talking about this theory of Stardates, this equation of Stardates, and frankly, I want to see it on Memory Alpha. Now, I could just put it there myself. It's a wiki. But if it's not legitimized, the rest of the community will just take it down anyway. So I need support for this theory in order for it to take off. So yes, like this video, subscribe to my channel, but more importantly than ever, share this video. Share this video with anyone who will listen. Get some traction on this thing. If you believe my argument here, if you think I made a good point, share it with the world. This is my vision. This is my dream. Live long and prosper, my friends. Captain's log, Stardate 100.5.
It's about fucking time.